So we finally have our last shape. Trapezoids. Do you remember what a trapezoid is? Sometimes people forget what a trapezoid is. So first we'll go back to what we already know, which is parallelograms. That number's a little hard to read, but I believe it's a 20. So we remember our famous double checkerboard here, where all the acute angles in this picture here would be 20, 20, 20, 20, 20. Do you remember what all the obtuse angles would be? Right, 160. So it's really tiny. You don't have to write all of them. You could just watch the 160s. And the whole idea of the double checkerboard is that you get this parallelogram in the middle. And if I just kind of blow that parallelogram up, it had a 20 in these corners and a 160 in these corners. So that's like we've already been there, done that. Now we're going to learn about trapezoids. And trapezoids really come from two separate checkerboards. So like here I've got 30, 30, 30, 30, 150, 150, 150, 150, right? Like that's a checkerboard. But the checkerboard on the other side is not going to match. That's got 80, 80, 80, 80, 80. What goes with the 80? 100, 100, 100, 100, right? So if I look in the middle here, I get this trapezoid, and if I blow that up big, it had a 150 and a 30 and an 80 and a 100. So it's quite different than the parallelogram. So we'll get more into it, but that's the basic gist. A trapezoid is a quadrilateral, but it only has one pair of parallel sides. So a quadrilateral with one pair of parallel sides. And I just abbreviated parallel. So here in this picture here, you see the parallel sides are those. And the parallel sides have a special name. They're called the bases. The bases are the parallel sides. Sorry, it's not right in here. Bases are the... Do it with my finger. The parallel sides. There we go. So in this case, these two are the bases. I'll just color them in green. The legs are the other sides. So we'll just color code them here for you. These two are the other sides. Those are the legs. And then we've got base angles. I'm just going to... Base angles, I'm just going to draw them. They would be here and here are a pair of base angles. And then I have a second pair of base angles there and there. Okay, so the angles, let's see, so it would be like angle R and angle A are a pair of base angles, and angle T and angle P are a pair of base angles. Then we have a mid-segment. Just like it sounds, a mid-segment is a segment in the middle. Segment in the middle. So AB is a mid-segment. And we're going to have a formula to find the mid-segment is top plus bottom divided by 2. Top plus bottom divided by 2. So for example, let's say if this was, 8 and this was 6, and I wanted to find the one in the middle, it would be 8 plus 6 divided by 2, or 14 divided by 2, or 7. And it's not always sequential like that, 6, 7, 8. It's just basically the average. Okay. So if we could do some examples, that'll help. So first example says, what about the bases of that trapezoid? Now you got to be careful. Sometimes it's on its side here. So if you see the little arrows, those were the two bases there. RS was a base, RS, and UT. Order of the letters doesn't matter, of course. The legs would be my other two sides here, RU, ST. Two pairs of base angles is a pair at each side. So like angle R, angle S is one pair, and then angle U and angle T are the other pair. Here's that base midline formula here where you would add top plus bottom divided by 2. So 7 plus 15 divided by 2. So 22 divided by 2, 11. Shut the door. Another one with that midline, 16 plus 12 is 28 divided by 2, 14. Excuse me. And that's it. Isosceles. We've had the word isosceles before. Isosceles means two equal sides. Same thing. An isosceles trapezoid has two equal sides, but it's always the legs that are equal, so it's always those two. And if what we're going to learn is if the legs are congruent, then the base angles are congruent. The base angles are congruent. This only works for isosceles trapezoids, but it gives us at least like some little more balanced numbers. It would be like 80, 100, 80, 100, where they would match on each side. Versus up here, like you had a pair of angles that added to 180, and then maybe a different pair of angles that added to 180. They still were same side interior supplementary, but they weren't like the same. So when it's an isosceles trapezoid, we get that nice same thing. So we're going to see that here. So for angle A, I'm going to take 180 minus 82, which would be what, 98? But on the other side, when I want to find this angle, is 180 minus 75, 105. So again, I get two pairs of angles that are supplementary, but they don't match each other. Same thing's going to happen here. 180 minus 125 is going to be 55, so those add up to 180. And then 180 minus 30 is 150. Those add up to 180. It's much prettier when you have an isosceles because then they match on each side. So here 140, 40, here 140 and 40. That's what we're saying, that the base angles are equal in an isosceles trapezoid. And how do I know it's isosceles? Is those being marked. So here I'm going to have 60, 120, 60, 120. It just matches better. Last thing here at the bottom is filling in, a lot of different angles, but when you look at it, it's really our old friend, the checkerboard, right? So this 80, if I fill in the whole thing, is going to keep zigzagging, giving me that angle 2 is 80. And then what are the other angles in the checkerboard? Oh, 180 minus 80 is 100. So angle 1's 100, angle 2 we knew was 80, angle 3 100. On the other side, and like another thing, you might not want to draw that whole checkerboard, you might kind of see the pattern. Oh, I see, like all the acute angles are equal, all the obtuse angles are equal. So this is going to be like 140, 40, 140, 40. It's just going to alternate. Now if you want to do the whole checkerboard thing, you can. Or you might be able to say, I see that angle 5 and 6 are 40, and then angle 4 there was 140. Last one is number 9. Loving this 90, because it's like 90, 90, 90, 90, angle 1, angle 2, angle 3, all 90. And again, it's just going to alternate here, 70, 110, 70, 110. Add in the 70 in a different color. So these are like corresponding angles. These are corresponding, same side interior. It's just our same rules from before. So 110, 70, 110. Then we just have a little note at the bottom that a trapezoid's not a parallelogram. It's easy to revert back, I guess, to what we already knew about parallelograms, but trapezoids are different. So just to do one quick picture, just to remind you, a trapezoid or a parallelogram might be like this, where, opposite angles are equal, but if you look at the trapezoid, you've got more the pairs that are supplementary there. So this is our last shape, trapezoid.